Okay, so we're just going to go quickly over the stuff we saw last day. We'll be in the same section again today, so hopefully we'll be able to reinforce any concepts that were missed. The first thing, of course, is just this general idea of the limit of a function. And you can read through this little explanation here, but the keys are that when we look for the limit, we're looking for the value of y, the value of f at x, remembering that y and f at x are identical, that we're approaching as our x value gets to whatever given point we're asked. Okay, so, and then the sort of the key here is the idea that the limit f at x exists if and only if the limiting value from both sides is the same. So if we approach the same point from either side, then the limit for the whole question, the overall limit, exists. If it doesn't, if from the left side we approach one value, from the right side another, then we say that the limit does not exist. So looking at an example here, this is our graph. This is the definition of our graph. F at x changes depending on which section of the graph we're in. That looks like this. But again, the key is determining what the limit is when x approaches 1. And so, again, you can read through what's written there. But the basic idea is, as I'm coming from the left side, the value, the y value that I'm approaching is 0. You can sort of see that I'm coming up this curve here, and I'm headed towards that point right there. If I'm coming down the right side of the curve, I'm heading towards this point right here. So the limit as I go, let's say the limit as I come from the left side is a y value of 0. The limit as I come from the right side, the y value is 2. And so the limit for this whole function does not exist. Another key here is to recognize that the actual point on the graph, the at x equals 1, is the point 1, 1. It is neither the limit from the left side nor the limit from the right side. And again, the overall limit for the whole question doesn't exist. But there's four different answers there. The limit from the left is 0. The limit from the right is 2. The actual value when x is 1 is 1. And the limit for the whole question does not exist. So 4 different things, and perfectly legitimate. Now, just repeating the same things with a little bit more mathy speak. We say that the number L is the limit of the function as x approaches the value a. So this is, again, how it's written. The limit of f at x as x approaches a is L if the limit as x approaches a from the negative side, from the left, is L, and the limit as we approach x from the right-hand side, from the positive side, is also L. Otherwise, it doesn't exist. So again, the two limits must be the same to say that the limit overall exists. And you can sort of read through in summary, some need to know things, fairly important. The limit may exist even if there's no value at that point. Okay, so in the example we just saw, the point f at 1 was positive 1. But even if it weren't, the fact that the limit can still exist even if there isn't that single point. We'll see one in a minute. We also have that the limit can be that value f at a if the graph is continuous. Just on a regular graph, the limit going towards any point is exactly the y value at that point. And then the last statement is simply that if the limit from the left side and the limit from the right side are the same value, the limit for the whole question is that same value. Now, looking at these questions from last day, each of these questions, if you sort of look at the f at x value, just x here, x squared, 4, these are all curves that you've seen before that you know are continuous. There's no issue with substituting any value in here for x or for any of these other ones. Remember, the two times we actually run into issues are if we have to deal with the square root of a negative number or if we have to divide by 0. If we don't have those two situations, then chances are there's not going to be any holes in our graph, there's not going to be any missing pieces, and if we don't have a piecewise function, of course, where the graph actually jumps around. So in all of these cases, when I look at the f at x value and recognize it as a standard curve that I've seen hundreds of times, my limits will exist, and they'll exist in exactly the place where f at x is. And so basically for the early questions here, all I have to do is substitute the x value that I'm approaching into the function f at x. So here -5, I substitute into here, and essentially I'm finding that y is going to be 5 in this case. So the limit on my graph, and if we looked at it really quickly, this is the line y equals x, or f at x equals 5. So as I go across to -5, my y value drops down, and it happens to be -5 as well. -5. The same will be true for all these other questions. In E, I've got a straight line where f at x, or y, is equal to +4. So essentially this is my graph. The limit as x approaches 1 is saying, as I walk along this graph, what y value am I approaching in the x equals 1 area? Well, I'm approaching the value 4 because that's the only value that I ever have on that line at all. And again, same sort of thing with any of the other ones. Here I have a parabola. It's going to be inverted. And so as I'm walking along my parabola, wherever it happens to be, I'm going to hit each and every value that's on the parabola at -2 specifically. To put -2 in here, we get 4 times -3 is -12, and so my limit will be -8. Okay, so again, the limit on any continuous function is just going to be the y value of that function at that point. Now, as we move forward, of course, we'll have much more complicated graphs throughout most of the examples. Here it says f at x is defined by the graph shown, and it's asking you to determine each of the various choices here. This is saying, what is the limit as x approaches -2 from the positive side? So I'm going towards -2 from the positive side. Well, here's x equals -2. Basically, somewhere on that line is x equals -2. And if I follow along my curve, the value that I'm approaching is that one right there. Again, f at x being 0. So the limit here is 0. As x approaches -2, the limit is 0. From the right-hand side. It turns out, of course, that it is the same from the left-hand side. As I walk along this curve, I'm approaching that value 0 from the left-hand side. That's not what B says, though. B says as I approach +2 from the left-hand side. So continuing on the left-hand side here, I'm going to be approaching this point right here. So from the left-hand side, I'm approaching the value 2. From the right-hand side, so as my x values decrease towards the 2, I'm approaching the value -1. And though the question doesn't ask it, therefore, if it did say what is the limit for the whole question as x approaches 2, you'd have to say does not exist. Okay, and again, that's because there isn't a single answer you can give me that makes sense from both directions, left and right, for the +2. The -2 would have been fine, of course, because I'm approaching 0 here, and as I said, I'm approaching 0 from the other side as well. Final question then says, what is f at 2? So what is the actual y value when x is 2? Well, I kind of drew over top of them, but in the original diagram, if you can see, in the original graph, this is a filled in value, this is an open circle, and so this is the actual value on the graph. The open circle, as it did way back when you did number lines, means that that point is not actually on the graph, but every point right up to it is. Okay, so just a couple more here. Determine if the limit exists at each point. So when x is 2, As we said, this is where x is 2. So what am I approaching as I go along the graph of f at x? I'm approaching this value right here. And again, I don't like the way they keep doing this, putting y values and x values that are the same. But in this case, as I approach x equal 2, I get a value of y equals 2 as well. And I get, of course, the same value coming from the other direction. I'm approaching that same point right there. So my limit in this case is 2. I'm approaching it from one side, I'm approaching it from the other side. The fact that it exists there is nice, but certainly doesn't mean anything. And we see that actually in the very next question. What is the limit now as x approaches 2? Well, again, if I'm following the curve from this side, I'm approaching that spot right there. If I'm approaching from this side, I'm approaching that same spot right there. And at that spot, f at x is 1. And so the limit, which is right up here, the limit as x approaches 2 from either direction is 1. That's what you're approaching. So remember, this is saying what am I approaching in the y values as my x value approaches 2? Well, as I go towards 2 in the x values, my y values approach that value of 1. It turns out that on this graph, this is the actual value f at 2. F at 2 is actually equal to the value 3. But that's irrelevant as far as the limit goes. The limit is just as I'm walking along the curve, what am I headed towards? Well, I'm headed towards that hole in the graph right there. And then finally, this one, hopefully you see, does not exist. And the reason for that is, of course, from the left side, I'm approaching this spot right here. From the right side, I'm approaching this spot right here. Clearly, they are not the same, and so overall, the limit does not exist. The limit from the left is a y value of -1. The limit from the right is a y value of 1. They are not the same, so the overall limit does not exist.